order shortly. Before we do, I just want to thank our chief and the fire department for their little service that they had for our victims from 9/11 from 16 years ago. Thank you very much. It's very good words that you said and everything that you did. So I appreciate your hard work prepping that and the memory of all those that were impacted. We're going to call our meeting to order. It is 6:02 p.m. on September 11, 2017. This is the Town of Greenville Town Board meeting. We're going to start with the Pledge of Allegiance. Please stand and face the flag. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Before we get started on our agenda topics, I just want to check with those that signed in to make sure that you are wishing to speak tonight, because a lot of times people just think this is just an attendance roster. So Jean Gofford, you're wishing to speak? Okay, thank you. Steve Nagy. I know Steve was here at one point. He had a nice bright shirt on.
His books are still here.
All right. Kara? Okay. Just checking. John Julius? You wishing to speak, John? Mm-hmm. Okay. And Steve Nagy, are you wishing to speak?
Yes, indeed.
Okay. And there's somebody marked as Hess.
Yes,
the Hesses. Okay. Thank you very much. All right. So this takes us to our agenda. I want to make sure the agenda was properly posted.
Yes, sir.
Are there any questions from the board on the agenda? Not hearing any, I'd take a motion to approve the agenda.
so moved. Second.
Andy with Mark as a second. All in favor to approve the agenda, say aye. Aye. Opposed, say no. The agenda is approved. Takes us to 3A. There's a presentation about the Lynn property geological study that will be done by Sand Creek Consultants, and also a restoration plan by McMahon Associates. So as we get ready for these, I see our gentlemen are here from Sandy Creek, and we've got Nick Vandehave here from McMahon, ready to do the presentation. Immediately following this, there'll be a public comment forum section. So just a reminder that save your questions and topics for that point. If you have some specific comments or questions, if these gentlemen are wishing to take those from you, they'll let you know. With that, Sandy Creek. Joel, do you want to introduce or?
Sure. Pete Arnstead from Sand Creek Consultants is going to be providing the presentation. Mark Dawson, who is with them as well, will be helping with the presentation. Pete probably can introduce himself and the members of his consultant team better than I can, so I'll leave it up to Pete to kind of introduce himself to the public and his firm so that they have a better understanding of their background, expertise, and education as it relates to this topic of study.
Before you introduce yourself, I just want to ask the board if we can see or not. If not, we should go down here. You guys see okay? I'd prefer that the screen be out towards the crowd, and I can't quite see, so I'm going to move down with Andy.
And then, can you hear me okay? No? Is this mic on? All right. How about that? Is that better? Got me? All right, well, thanks for inviting me here this evening. My name is Pete Arntzen. I'm with Sand Creek Consultants, and I'm going to talk to you about the investigations we've done on the reported karst feature in a drainage way here in Greenville. First, I'm going to give you some background on who we are and what our qualifications are for doing this. Then I'll give you a little executive summary to condense it down. From there, I'll go into some details of the work that we did, and then I think we'll take questions afterwards, or are you going to wait till after the other presentation? We'll see how that one goes. I'm just wondering if I can see this. I have a master's degree in water resources from the College of Natural Resources in Stevens Point. I'm a licensed professional hydrologist and a licensed professional geologist. I have 27 years of consulting experience doing soil and groundwater, principally contamination investigations and remediations. Dr. Dave Osvath, my co-worker and mentor, he was on my thesis committee in grad school. He is currently the chair of the geology department at University of Wisconsin-Stevens Point. He's been consulting first with me at an engineering firm up in Weston, and then more recently since I've been at Sand Creek. So in addition to his education services, he does consulting services, again, when I got high-powered things I want somebody to look at. Mark Dawson here is my boss owner of Sand Creek. He has 30 years in the consulting industry, working primarily with agricultural issues, and again, soil, groundwater, releases, investigations, and cleanup. So that's who we are. We were awarded this project, and the first thing we did was try to do our homework, try to do the research, see what other geologists have done, what type of references are out there. And we're going to talk about karst. Karst is a bedrock phenomena, and so first we looked at the geologic conditions, the geologic map for the Greenville area, and it looks like this is the drainage way. Pretty sure. Did I just change that? Touch that? Oh, all right. Go back. All right. So it looks like this geology in this area is the Sinipi group of the Ordovician age. You know, we can start talking about geologic ages and 250 million years ago and 300 million years ago, and that's when these formations went down. But it's, and this is, again, it's a carbonate dolostone formation primarily. But that's important to look at because there's a lot of information about karst out there in Door County and Kewaunee County. There's been a lot of publicity and a lot of research has been done. And really, that's how my involvement with karst is, has really ramped up. I'm working with a group in central Wisconsin that's worried about groundwater contamination. The folks over here in Kewaunee County are a step ahead. They got different conditions, but a same type of situation, preferential flow to bedrock that affects private water supply wells. In central Wisconsin, we got sands that provide little filtering and have poor attenuation potential for cleaning up contaminants from the surface to the groundwater. So similar problem, different type of conditions. But nonetheless, it's that emphasis on karst in Kewaunee County that really brought an emphasis to this. And so first, we're talking about a karst feature, karst topography. What is a karst? And karst is a type of landscape where water dissolves the underlying soluble bedrock. And then what is soluble bedrock? Dolomite and limestone. There are others, gypsum, halite, things like that. But those are the carbonate ones that we talk about. And here are some classic landform features indicative of karst. And looking at this graphic, the karst features typically start at the top of a watershed, at top of a landscape, because they are formed by water, primarily running water, draining water. And so hence you see this would be one of those disappearing streams perhaps, and these formations. And so the idea is that there has to be a way for the water to go. And it takes quite some time to develop these type of karst features. So again, the karst key is a bedrock feature. It's not a soil feature, it's not a glacial feature. at the surface in the soils, you can see evidence of perhaps karst features underneath the soil, but there again, the thicker the soil horizon above that gets, the less likely you're going to see any manifestation of any rock surface karst features at the surface. And that's been part of the tricky thing in Outagamie County, really as opposed to Kewaunee and Door County, is that you guys had a glacier sitting on there for a long time that left, 40, 50, hundreds of feet of sediment. So even if there would be karst features there, they're buried under that soil layer. That one. So, more geology for you. Bedrock geology of Wisconsin. I guess the key thing here is that this is the Silurian dolomite that is the karst investigation area in Door County and Kewaunee County, and has really been a focus. And that is of, Silurian age. This is the geologic age, going back from formation up to most recent. The most recent rock formation we have in Wisconsin is the Devonian age, and that goes back 250 million years ago. So essentially, Wisconsin has been above water for the past 250 million years, but for 100 million years prior to that, it was underwater, and these formations got laid down. Cambrian sandstone is the deepest. This is when fossils first started appearing. And then you go up through the Ordovician unit at different units, Silurian. And so this is a geologic timeline of, again, 200 million years or so. After all those rocks had been laid down, glaciers came down and wiped through them. And so you can see the Silurian, we get deeper as we go east to west. Sorry, lost pronunciation. Maquoketa Formation. That's the shale, and that's the Niagara Escarpment type unit. Then you get into this Sinipi group, which Sinipi and St. Peter Formation and Prairie du Chien group, dolomite, sandstone, dolomite. You can see there's that transition kind of right around where we are, so there isn't so clear of geology there. But this area loops down and over this way. Well, this mirrors the globe of the glacier that came down there. Up here, these are all Precambrian rocks, crystalline rocks, granites, gabbros, gneiss, those things. So this had been pounded by glaciers much more frequently. Cambrian sandstone, okay, so that's resisted it, but essentially as you've had less glaciation come through, you get more of those historic bedrock deposits. Looking at a little bit closer, the latest geologic map of Outagamie County puts us right there. It puts us in the Sinipi group, dolomite and limestone with some shale. That's consistent with what we've seen. Underlying is the Anapi with the sandstone, the St. Peter sandstone. So the difference here, Kewaunee and Door counties have Silurian age sedimentary rock exposed in near surface and exposed to the effects of dissolution, essentially karst forming factors, forces. Outagamie County has Ordovician age sedimentary rock, 30 to 60 million years older, and scraped free by glaciers, more amount of glacier action. These are those formations. Again, geologic timeline from the Precambrian rock, Cambrian sandstones, timeline 490 million years ago, 470 million years ago. The Devonian, the earliest one, 354 million years ago. These are the units. You just got a piece of this over on the edge of the Door County, or actually I think it is in Kewaunee County. And then you got the Silurian rock, that formation, and then the Ordovician. And we're looking at really this group, the Sinipi. So if you look at this timeline, this is much younger than this. This has been buried a lot longer. So they're both limestone, dolostone, some sandstones, but they're different rocks. They have different characteristics, formed under different factors, different fracture patterns, different mineralogies to a certain extent. This is where I was talking about those lobes coming through, and the question is, you know, why does Door County, Kewaunee County have their karst issues? Well, they call it the Silurian escarpment. The Lake Michigan lobe came down this way. The Green Bay lobe came down this way, kind of split right there, and so that area was essentially in the trough between the two glaciers. And so odds are this was covered by glaciers to a certain extent, but you know, here it was thousands of feet thick and thousands of feet thick, and it's probably much less here. So it didn't get that pressure, that scraping action, those forces that glaciers are so noted for. And you see this driftless area. If you think back to the other map, this is the Silurian dolomite, and then you get the Ordovician, and that slopes down to this driftless area. This area, Cave of the Mounds, lots of caves down in that area. In that Ordovician unit has caves, has fractures, has karst, has those types of features. But this has been exposed to weathering for millions of years. And so the effect of rain over that time can be similar to the glacier lobe. So again, it's all about erosion. Besides the bedrock maps and looking at that information, historically there's been research done here. Early on, 1929, Thwaites did a field report, Glacial Geology of Outagamie County, Shawano and Langlade. 1957, LaRoe, Geology and Groundwater Resources of Outagamie County. Geologists have looked at this area before. Brown, this is the bedrock map. And then more recently, local investigations have been done. The 2014 A&E Geosciences Report and Observations, Towering Pines. They did a lot of homework on that one. They did some investigations. They had well logs. They did some evaluation. Their reports were essentially critiqued by a geology professor in Green Bay. And there was an iterative process. And so that turned into be a pretty darn useful and document. And then more specifically, 2015, PSI did a subsurface geophysical investigation in preparation for sanitary sewer that was going to be installed in there. And they came through and they did their borings where the path was. And they hit rock and they did rock corings. So we had some geologic profile. And then McMahon supervised the installation of that sanitary sewer system. And so we have some information about that. Where did they have to dig into rock, and what was the quality of that rock, and could we blast it, did we have to dig it, etc. So we looked at these things, and none of them mentioned a karst formation or fractures or such. Now, these two geologists in their research never mention karst, don't mention really the dissolution factors, and so that's not definitive, but it's telling. There's lots of soil. That was a while ago. They don't have much well logs, and you don't see it on the preliminary map. They talk about the Prairie du Chien formation having historic karst features, pre-glacial, pre-Silurian karst features, but not the one above it. So again, came up short on any definitive evidence. I did hear anecdotal reports. We've seen reports about karst features and swirl pools and historic caves and sinkholes and things like that. But again, nothing that I determined to be tangible. So we thought, what's one way to figure out what the geology in that area is? You go and put in some test pits. And so we checked in with the feds and looked at the Corps of Engineers. Can we go and dig test pits in wetlands or in drainage ways. And they came back and say, yeah, you can get a general permit of that. Just don't make too big of a mess and restore it when you're done. We asked the DNR and the county, and there are some sensitive situations with this area. And we were asked, you can do your test pits, but stay out of the wetlands, stay out of the drainage way. So, okay. We had some proposed test pit locations. We came out here beforehand and looked at them, and this is where reality meets theory. Dan Klansky went out there with me, and we identified these locations and the pros and cons, the braided stream area. This is the sinkhole area, but the maps we see indicate a pretty big area. We found some areas where there were piles of rock, and those piles of rock were pointed out as being places of swirl pools and maybe a connection to the underlying karst features. So those were of interest. Here, this bend was identified, thank you, as a potential karst feature that, you know, there's a reason why something caused that bend. And so we tried to pick locations. We were limited in terms of our access. We didn't want to go clear out a bunch of trees. And again, we didn't want to get too close to the existing stream. And there are wetlands along here. We couldn't go on the north side because that's where most of the wetlands are located. So we pick our shots and this was a location where there was a hole in the grassy area, really reminiscent of some of the holes that were shown in that stream study where they showed the water going down there. I also might add that prior to locating these test pit locations, I walked the stream in April and, you know, top to bottom to see what it looked like, see what we saw. And I saw drain tile feeding into the water along here. The whole stretch had water. The bottom was getting pretty silty. I never walked on rock, even though I was quite a bit below the, you know, the adjacent grade. So yes, they did dig down quite a bit past the previous riverbed. But again, I never clearly hit rock really until you get down to this point. And so that was generally consistent with what we expected. We looked at the engineering plans and saw their plan and profile sheets that show clay material near the surface up here, which pinches away and grades away to silty sand material. There were reports of some real clean washed rock indicative of water movement and effects. And then at the very base, this is where they had to do a lot of the hard rock removal, digging down into that limestone, dolostone rock to get to their depth. And so they were several feet below that. And so really this strip was identified as, you know, again, the clay pinching out and shallow to rock, accessible with a backhoe that we had. So that's the background of how this place came to be. This is that profile that I was trying to describe, in that going from east to west from Municipal Drive, the superficial soils here are glacial till, clay glacial till, and this is a drainage way. It's been a drainage way for probably a real long time, maybe going back to pre-glacial times. And so this is a glacial deposit. This sand and gravel, rock, silt, and clay, some of it seems to be water deposited, probably glacial, probably outwash of some sorts. It could very well be aeolian, wind deposited. There are sand dunes in this area, and that gives you a well-sorted formation. But it's sitting on top of the dolomite, and that seemed to be a pretty consistent unit all across there. And so in looking at that, again, we were still well below the surface. Our deepest test pit, I think we found it at maybe less than 5 feet, 8 feet, 10, 15 feet as we go up in depth below. And so we did this and started to thinking that, you know, what was the nature of that disappearing stream? Well, this clay formation, and this is where we saw a bunch of the drain tile feeding into that creek, that is limiting infiltration and limiting flow. It's a fairly narrow stream path. It overflowed in the spring, the original path. So once it gets who's operating this thing anyway? That the initial flow, it keeps going down in the springtime, but as the season wears on, you don't get so much runoff. And this water that normally flowed on top infiltrates through the sand, and that's the disappearing stream. The capacity of this, these unconfined, silty and very fine sands exceeds the rate that water's going down. That's why it infiltrates, and then it flows likely along the top of the bedrock. And that ties in with what we saw of the borings in the area. Now on this one, we wanted to give an idea of the wells in the area. We obtained a number of the private well logs in the section 22 in Greenville. And I'm pretty sure universally they're all screened, certainly through the unconsolidated materials, typically through the upper layer of dolostone, sometimes terminating in the sandstone, oftentimes going to that underlying unit. Now I can't say for sure if these are variations within the Sinope formation or if this is Sinope, the Anape, the St. Peter sandstone, and then this would be the Prairie du Chien, but the wells were cased 40 to 50 to 60 to 70 feet down, and the wells were typically 150, 200 feet deep. So that was one of the concerns expressed, is there a threat to private water supply wells, regardless of what this function is. So, and here are some of our test pits. I got a lot of pictures, but essentially the process that we started, we began on the southwest side, the low area, the discharge of that stream, and dug a pit kind of near the stream but not too close to it. And we found this silty, very fine sand unit that was consistent throughout. Above that, there were a couple feet of topsoil and probably alluvial deposit sediments. And then we started hitting rock that at first would come up as small chunks, and then it would come up as larger chunks, and pretty soon we were bringing up flagstone-sized chunks, and then we couldn't go any farther. So that's how we defined it. That zone typically extended a foot to 3 feet total, grading down there. As we worked our way up, what we found at the bottom was consistent. We would hit that silty, very fine sand layer that appeared to be residuum from the limestone, is all calcareous. And when we hit it, we could get down to it. Our easternmost test pits, we did not hit this flagstone. Our backhoe couldn't reach down there and pull that up. But otherwise it was consistent. In those middle zones, this was a location where we saw a pile of rocks kind of sticking up there, and that was a reported swirl pool location. And so we thought we'd dig next to it. We went down, we saw the rocks and the cobbles extending down 4 or 5 feet or so, and at the base of that we saw a clay unit, and underneath that we saw the sandy unit. So appeared to be man-made influence. This is probably not a natural geologic deposited pile of rocks. And so again, these rock piles in this low area started getting us thinking, how are these rock piles getting there? Somebody put them there. Well, it's been a farm field for 150 years, let's say. What do farmers do with their field stone? They stack it off to the side. You know, get it out of the way. Did they bury it? Did they dig a hole there and put this in? That's one scenario. Another alternative is that a long time ago they piled it up there, and this is a result of that stream flooding and depositing and filling in around it. And so that was a curious location. That was test pit 3. And at the place where we found a hole in the apparent wetland area, where we dug down into it, it didn't go anywhere. It was a hole. I stuck what did I have? My sharpshooter, trying to look, and it fed from the side. We thought maybe it was a drain tile feature. But again, we dug through it and dug down past it and really didn't see anything of note. And as we made our trek to the east, all these features got deeper. The topsoil tended to get thicker. We started to get more development in the B horizons, the subsurface horizons, the argillic horizon, and so you can see the soil formation factor. Our northernmost or easternmost location, this one had almost 3 feet of topsoil on it, and underneath it a series of layers that look like annual depositions from flood is what I interpreted it. But again, this area has been ag for a long time, and it's got a slope, the clay soil, it's been eroding. Where is that eroding going to? Well, it's collecting in this drainage way. And so go back to it, karst being a surface feature, a surface rock feature. Walking along here, digging pits, we never really saw anywhere where the rock was near the surface. The places where we dug, the places reportedly that were dug along here and also for the sanitary sewer, they found the same thing. You hit the top of the rock and you can get through it, but if you try to go down any depth, it was very, very difficult. It's not eroded. It's not... It hasn't seen much weathering. So yes, those upper couple feet have seen the weathering. You get down deeper and there was really no evidence for it. And so based on that, we came back and we wrote a memo and submitted it. This is what we found. This is our take on it. And sent it on over. Oh, wrong way. And what did we say? We were asked a couple questions from the beginning. Were any karst features identified? Did we go and investigate and find any karst features? And are water supply wells at risk from stormwater runoff in the drainage way? The answers to that, in our professional opinion, professional scientific opinion, no and no. The karst features, we went and we dug holes. It's a hit or miss proposition trying to find out what's on the surface of the bedrock from 5 feet or 10 feet above grade. The evaluation of the potential threat to private wells was based on, is there a likely preferential channel from this shallow formation into the deeper bedrock units? No, we didn't find one. And furthermore, those wells are cased down, again, through a couple formations, 40, 60, 80 feet deep. So they would be mostly sealed off from the formations that might be affected by these shallower, theoretically preferential migration paths. And we were doing some sampling in the neighborhood for the co-op, and we thought, well, let's grab some samples of chemistry and analyze for chemistry that might be suggestive of surface water intrusion. The idea being that carbonate bedrock, dolomite and limestone, is going to have high alkalinity and high hardness from the dissolved calcite and dolomite minerals. And so we looked at those wells. Surface water runoff might be expected to have lower concentrations. If it's rainwater, it hasn't had much time to dissolve those minerals and whatnot. We saw some pretty consistently high concentrations of alkalinity and hardness, which is what you would expect from wells screened deep in those limestone aquifers. The sample of the surface water, not clearly so much so, because that also had high calcium or high hardness and alkalinity concentrations, which is no doubt from going through these calcareous clays and such. So it wasn't as clear as an indicator but there's clearly no indication that there was surface intrusion, and the chemistry is consistent with the carbonate limestone bedrock. So hence our conclusions of no and no. Any questions now?
Well, before we let people ask questions, I just want to thank you, Pete, for presenting this. I feel like I deserve another college credit almost.
Just after reading the report. Your wonderful presentation, so thank you for that. Those that do have questions, I just ask that you stand, and if I'll repeat your question, but we do need your name and address as well as who you're representing. So if you want to come up, if you got a lengthy question, feel free to come up and use the microphone. It'll be a lot easier to have that recorded. So if anybody has a question, feel free to raise a hand, and I'll kind of be the moderator here and call on you, and we'll ask Pete to answer the question as best he can. So Jim Ecker. So Jim, stand up and.
Hi, Jim Ecker, N2044 Manhattan Road. Do you have, it sounds like you confirmed that it's probably likely seepage down, but not necessarily through the bedrock. Were you able to decide or determine where the water comes out that does seep down at all?
Well, that drainage way continues on. The drainage way continues on out of that, the specific area. So discharges out through here, and this drainage way continues on, and in fact, the sanitary sewer goes out and along that way. When we were encountering the rock, it's allowing that preferential flow through it, and it's more fractured at the surface getting down there, but once it hits that pretty competent rock, which is actually down below the bottom of the sanitary sewer at that point, I would expect it to flow along there, and really, realistically now it's probably following the bed of the sanitary sewer line, which again gets below that rock. But there again, that was a factor in wondering why there would be a karst feature here, because again, you would need some place discharging, and that was my first thought. You keep on looking farther to the west, and where are the discharge? Where's the water flowing? And it wasn't clear that there was a stream. There was a discharge location that I found, and so we seem to be missing the factor of flowing water, at least currently. Is that good?
You answered. Right, thanks.
Anyone else? I got a few. I'm going to start from front to back. So go ahead, sir. Make sure you stand, state your name and address, and if you're.
Can you go back to the map that you just had? I'm Mike Hare, N1132 Churchill Road.
Okay.
I got the house right here.
Okay, Mike.
So I've been watching this with a lot of interest. My one comment I got before the dredging this spring, you can see that. That's where the water overflowed when the water rained a lot.
Mm-hmm.
And it overflowed. It also overflowed here. And then I've got corn stalks in my property to prove that it went right into my property. So the
Never.
water
So you
does-
never planted corn. It just planted itself there. Is what you're saying.
Corn stalks don't reproduce. But that water would go, it's supposed to go right here. There's a
Okay.
ditch right there that goes straight down the property line.
Yeah.
So I've watched that. I personally am worried about the water overflowing into my property, and I'm also worried about my water. And I'm wondering if there was a karst, this is a question for you, if there was a karst feature before, is my groundwater better now because the karst was obliterated, or whatever the word is, it's wiped out? Or if there was a karst, is my groundwater better now or before? Because I feel like the water is being filtered now, and so it's probably better. You know, versus where if there was a karst and the water was going into the karst, was it getting into the groundwater more directly? That's my question.
Good question. It depends on where that preferential recharge is coming from. If it's a clean surface water, nice filtered through vegetated strips and whatnot, and you know, right, it says that you can see where the stream has meandered, but the picture I saw in that A&E Geosciences study showed that the original stream followed that edge fairly closely, and was really shallow, just a small little trough. Couldn't convey a whole lot of water, and so particularly in spring, it comes over, floods the bank. It was only during those flooding conditions, really, that the swirl pools were noted down in this area, and there was some holes noted, perhaps channeling coming in from this side of the stream. But for most of the year, it, well, and as I explained, it would dry up down here, often still expanding down that way. And so, previously, when the water would overflow, it would take the sediments, and you know, the flood water is going to contain your clays and silts and your fines, your sand is going to stay in the bed. And that would eventually deposit out. You'd have high alkalinity and hardness, but again, depending on where your source area was coming from. If this area was used for land spreading manure or such things, and the karst feature, you probably want the karst feature destroyed. But now that said, nobody's talking about a destroyed karst feature because the karst feature is in the bedrock. And we never made it down to rock in these other ones. They stopped. So that's what I was saying. There could be a surface, again, a pile of rocks that could be a source of preferential migration downward. But it's there was no fractures, cave, etc. destroyed by any of these actions. Potentially access to those theoretical features could have been limited by lowering the water flow. It doesn't flood over there and can't get to those kind of feeder areas anymore. So in that respect, I think you're more likely cut off from any surface water flow. But your well, odds are, and I may have looked at it, is cased down deep through clay, sand, fractured limestone, maybe sandstone, and into there, and so it's sealed off. You're getting your water from down deep, odds are, regardless of the karst features here.
Okay. Some more questions? Mr. Julius?
Julius, Highway 90, Nick. Did you contact any of the previous families or the family that owns the land, like the Ulmers, or did you contact the Steinockers?
No,
Did you contact Pete Schrader?
no.
Did you contact the Outagamie County? Did you contact Professor Lukjai, all of which can identify where the water went down in the ground and the whirlpool and where they put the rocks in? And they put the rocks in a hole in the ground. They didn't pile them up or somebody buried them. They kept throwing them in, and they disappeared. And so, first of all, in this area is where the hole in the ground was. And did anybody point that out to you so you dug in the right spot?
I didn't have access to it. When I watched this ditch line, we actually came up here and found an apparent hole, some rocks by it, and the hole going down right on the shores of the new ditch line there. But again, we were asked not to dig into the ditch line, so we had limitations.
Well, I would think, if you had asked Outagamie County and the people that could have made a difference, or Scott Kinky, we would want to find out if we have a fracture in bedrock that is taking the water in the place where Melvin Loudon went in, where the rocks were piled, where we've been talking about over the years, to see what is there. That's what you needed to discredit, that area. And if you have, my understanding, minimal value of geology would be if we have cracks in the bedrock. And you only need to look at an overhead picture, which I have along tonight, several of them, taken from on our farm. You can see a whole bowl area in the soil all the way from Lyons Park way around to on the Palmer or Lynn property, where it's all eroded, and there's the center of what looks like a volcano. Now, over thousands and thousands of years, it's my guess that water eroded and went down in that hole in the ground. And how do you explain that that one person went in there on a rope? Not too hard for me. If you have a fracture in the bedrock, and already water, how many years have we farmed here? Not many. How many years has it been since people started production agriculture with tractors? Not
So
that.
my question is, do we have questions that Pete can respond to as compared to pronouncing some information? So that would be.
Well, what I want to point out to the crowd is that I want to have dug right where the hole in the ground was, and that should have been identified by many people that could have seen it or have seen and witnessed, so that we would have dug there so we would know. But that is where I think the main concern for me over the years was that that's a special place where Melvin Loudon went in, and with the fracture in the bedrock and thousands of years of water washing down, and you can see it's evident from the air.
So
Then
John.
that area would have been
John.
where in that crack, it might have been this big.
Mhm.
But you could lower somebody in there, and again this week, we just went to one person, my sister and I, whose brother was there that day. And he said they couldn't see the bottom, just like the others have said.
What Pete can answer is why didn't they check that area? And Pete said that at the beginning, that he checked with federal agencies, Army Corps of Engineers,
state and
Outagamie
county,
County, and
they-
DNR, and they weren't allowed to touch that area.
But then we can't say that there isn't a karst feature.
What Pete is telling us is where the test pits are. There was no identification, no areas of karst.
Well, my concern is the implications to the town, to the residents, of what we had going on there. I think in the long run, what we're going to find is that where the stream, we didn't do a stream cleanout, we did a stream moving, is what we did back here. And I think that in the long run, what the town did is going to do us a service, but we went at it totally the wrong way. We are going to take water away from where the major karst area is to get it to the stream down, a navigable stream downstream. And for many years, and before the Elmer subdivision, many people were saying we should be doing a study so we know what we have. And that's what some of us are contending, why didn't you do that? And then you decide how you're going to get the water from the housing developments to the navigable stream.
And you're going to steal the thunder of McMahon Associates, so don't go too far into that. All right.
Thank you for your time.
But
Yep,
just to
thanks, John.
address that a little bit, the concept of a giant sinkhole and a giant cave, the sinkhole coming before the cave, you kind of think it'd work the other way around. You'd have a cave that would collapse and create the sinkhole. Could have been a cave next to a sinkhole, although this elevation is pretty flat down here, and that might reflect back to your whole bowl area. But that's a pretty big sinkhole, and places, Florida doesn't see that size of sinkhole. And, the southeast part of the state, they tend to be small and readily identifiable with a clear drainage point. But part of the thing, going back to those glacial ages or geologic ages, the Sinope group between the two glaciers, it had been eroded by ice, by rain by freeze-thaw action for tens of thousands of years, perhaps. Whereas this stuff had been buried underneath a glacier and scraped clean for, at least 2 or 3 glaciations. So any karst features at the surface probably would have been scraped away, which means it would have only left the past 15,000 years, 10,000 years for those formations to develop. Now, yes, they could have been pre-glacial, pre-Silurian caves, and I can't say that there's not. Didn't find any indication of them. We dug down there, saw no reason to believe that that would be the case, but really, it just hasn't been long enough for that type of geologic karst system to be developed. Again, you can look at the southwest part of the Cave of the Mountains. That's that same formation, never covered by glaciers, and so it has had water eroding it for millions of years probably. And that's enough time to form those formations. That's the time to form a discharge. And that was part of the point of differentiating the geologic units. They're different rocks. The dolostone tends to be a harder rock than the limestone. Yes, they got different formations, different fracture patterns, etc. But there again, that was part of my reasoning. There just wasn't time for this to form. And if it formed prior to the previous rock groups, and then got covered with 10 to 100 feet of sediments, it's tough to make an accurate evaluation that such a thing could have occurred. And as you pointed out, as the drainage way has been flowing for a long time, if there was a feature in there that would allow preferential flow, you'd figure that 150 years of agricultural runoff going down through there would leave a fair bit of sediments built up there. And so there again, I couldn't make it work with my conceptual site model, I guess. And, everybody says that this feature starts at the land surface, on top of the soil. So it's not just a hole in the rock that's the actual karst feature that would dissolve and make a cave and fracture pattern. But for some reason there was a conduit through the soil that maintained itself for long enough to dissolve a cave, or at least to get access to a cave. So I don't have a good explanation. I can't say definitively that your theories are wrong. I'm not discrediting anybody's trip down into a cave, but I didn't see it. And I have a hard time making that fit with, again, my understanding of the geology of the area.
Can you address the aerial views that you looked at in terms of looking for potential karst type structures?
Well, the A&E Geosciences report included a nice set of historic air photos that showed how this drainage way varied. But you can look at those and see patterns on the land surface. And if you look at some of the karst topography, you can see green checkerboard patterns when it's right near the surface. Or you can see, again, a distinct trough, a hole holding water, those types of things. And we didn't see any of that for this area. In fact, I spoke with Dr. Maureen Muldoon prior to this, and I spoke with Kevin Erb in UW Green Bay, and asking about the karst features. And they talked about the presentation they gave back in October of 2014, and none of them could really direct me to a karst feature in Outagamie County. They said they could exist, but they've been covered up by soils. And so
They
and that's what they contended. They probably do exist, but they're way down deep and down below the soil.
No, they're exposed into the open, you can go and see them.
Okay. We need to make sure our comments are to the questions so that everybody can hear, and we get this recorded for those that view this later. Jean Goffard's got a question next.
Jean Gofford, N853 Julius Drive. Just from my father and from Elder Dell and stories I've heard, didn't the water, I thought the water came out, there was a place that came out on Elder Dell's farm that they would, he and his wife would watch it come out, wasn't it?
No, they would watch it go in a portal where I pointed out on the map, and it came out 2 places in Churchill subdivision.
Oh, Churchill, okay.
That was the Dell.
Do you have a question?
Dell farm, yeah, okay.
Do you have a question at all?
So
For
how would
Pete?
you explain that? The water coming out, because you said the water consistently.
Flows
Flow
here and
there,
flows out
yeah.
here, although granted, flood times, it goes this way. I'm mainly referring to groundwater. Groundwater flow as opposed to the surface water.
Okay, so if the water went into this hole, could it have come out way over in Churchill subdivision in a different location?
Yes, if the water was high enough. That area is pretty flat down here, so it's got to, flow downhill. If this area where it's discharging is higher in elevation than where it would be sitting in this cave or some other feature, then no, the water would actually flow from here down this way. But again, you'd have to have an outlet for it to discharge to, and looking at the elevations of where we're seeing water flowing and on this side, that seems unlikely.
Next question, gentleman in the red hat.
Carl Lavendroff, N217 Municipal Drive. I was just wondering, did they see, or the areas where you couldn't dig, did they see the reason why you couldn't dig there?
Reasons for not being able to dig.
No, they just said, asking why we were limited. I think probably because of the work that had been done there previously, they didn't give a specific reason why. I explained that the Corps of Engineers allows these investigations and these types, but they said, please stay out of the drainage way, please stay out of wetlands.
And then, like where your rock piles are, I mean, you don't put a rock pile on a mound. If you got a hole in the ground on your farm, you throw it in there to get rid of it, to fill it up. So, I mean, if you got a backhoe, how come you just didn't dig down? I mean, it only took you a couple of minutes to dig down, get rid of that rock pile just to see what's under there.
Well, and that's what we did on the one location where we dug at a rock pile, and that's where we found it.
I thought you said you went down the edge of it and you didn't dig your pile up.
Granted, yes, we did scrape along the edge of it. It's an access thing. And, but figure if you can see the edge of the pile, you can infer what the rest of the pile is looking at. But really, I thought it was interesting in that underneath those rocks, and we had topsoil through there, so evidence the thing moved down, there was a fairly thick layer of the red clay, and underneath that was it. So again, are these events, flood events, that are allowing preferential flow through these, the gaps in the rock pile to get down there and actually accumulate sediments over the, I think mostly since the agriculture has been happening in this area.
Okay, so then where you dug, that's where you can state that there is no cars, but where there isn't dug, you can't.
Right.
Okay,
Right.
thank you.
Mr. Irk, we'll come to you next.
Rick Erk, W6844 Apple Tree Court. I was wondering, with your vast knowledge of geology, fractures in the limestone layers or the dolomite, whatever, cause groundwater to flow away quickly down into the substrata or whatever, and can cause these whirlpools. Can they be as big enough and wide enough to lower someone down in there to check it out and still not be considered a karst?
No. karst is essentially inherent to carbonate bedrocks, dolomite, limestone. Gypsum is a calcium sulfate that also can develop it. It's a little bit what's the difference between weathered rock, and I talked about going through the top of the weathered rock and the blocks and the flagstone, and